What specific problem does the proposal of multi-LLM collaboration aim to address in the context of language model development? And why is this issue significant in the current landscape of AI?
The proposal of multi-LLM collaboration aims to address the significant issue of underrepresentation in data, skills, and user diversity that a single large language model, LLM, cannot adequately capture. This is crucial because a monolithic LLM struggles to reflect the intricate diversity of real-world language, leading to outdated knowledge, limited task coverage, and biases that fail to represent the pluralistic values of its users. The current landscape of AI is characterized by a race to develop a single best LLM, which overlooks the need for models that can collaboratively address the varied and evolving needs of users and tasks. By advocating for multi-LLM collaboration, the proposal seeks to enhance adaptability, efficiency, and inclusivity in language technologies, ultimately promoting a more equitable and effective approach to AI development. This shift is significant as it encourages a decentralized and participatory model of development that can better serve the diverse needs of all stakeholders involved.
How does the proposed multi-LLM collaboration methodology work? Please illustrate the steps involved in implementing collaboration protocols at API level, text level, logit level, and weight level.
The proposed multi-LLM collaboration methodology operates through 4 distinct levels of collaboration: API level, text level, logit level, and weight level. At the API level, LLMs interact through defined interfaces, allowing them to share outputs and inputs seamlessly, which facilitates integration into existing systems. The text-level collaboration involves exchanging generated texts, where one LLM's output serves as input for another, enabling cooperative problem-solving or competitive debates to enhance factuality and reasoning. In logit-level collaboration, LLMs mix their logit distributions during decoding, allowing for a more nuanced generation process that leverages the strengths of multiple models. Finally, weight-level collaboration involves the integration of specialized components, such as adapters or mixtures of feed-forward layers, which are trained independently and then optimized together, allowing for a unified system that benefits from the expertise of each model. Each of these collaboration protocols provides a structured approach to enhance the capabilities and adaptability of language models beyond the limitations of a single LLM.
Can you provide a simple example of how 2 language models might collaborate using the text-level collaboration framework mentioned in the paper? Walk me through the interaction step by step.
In the text-level collaboration framework, 2 language models can interact through a cooperative approach where one model's output serves as the input for another. For example, Model A could generate a draft response to a user query, such as summarizing a complex article. This output is then passed to Model B, which reviews and refines the summary, adding additional context or correcting any inaccuracies. After Model B processes the input, it produces a revised summary that is more accurate and comprehensive. Finally, this refined output can be presented to the user, showcasing how the collaboration between the 2 models enhances the overall quality of the response. This step-by-step interaction illustrates the potential of multi-LLM collaboration to improve factuality and reasoning through shared outputs.
What theoretical or practical advantages does multi-LLM collaboration offer over traditional single LLMs, particularly in terms of efficiency, data representation, and user diversity?
Multi-LLM collaboration offers several theoretical and practical advantages over traditional single LLMs, particularly in efficiency, data representation, and user diversity. In terms of efficiency, multi-LLM systems can dynamically activate smaller specialized models for specific tasks, reducing the computational overhead associated with using a single large model for every query, as seen in approaches like Matformer and branch-train merge. Regarding data representation, multi-LLM collaboration addresses the underrepresentation of diverse data types and skills by allowing specialized models to cover gaps that a single LLM cannot, thus enhancing the overall knowledge and adaptability of the system. Furthermore, in terms of user diversity, multi-LLM collaboration democratizes language technologies by enabling contributions from a broader range of stakeholders, ensuring that the needs and perspectives of underrepresented users are incorporated into model development, which is often overlooked in single LLM approaches. This collaborative framework not only improves the factuality and reliability of outputs, but also fosters a more inclusive representation of cultural and social values.
What specific methodologies were employed to validate the effectiveness of multi-LLM collaboration, and what datasets or metrics were utilized in these evaluations?
The paper discusses various methodologies for validating the effectiveness of multi-LLM collaboration, emphasizing the need for specific evaluation tasks and datasets tailored to assess collaborative performance. It suggests designing tasks where multiple models are evaluated both separately and in collaboration, such as ablation studies that withhold certain data types or evaluating multi-agent collaboration to tackle complex problems. However, it notes that existing research primarily relies on traditional single LLM evaluation metrics, which may not adequately capture the benefits of multi-LLM systems. The authors advocate for developing a detailed evaluation methodology that specifically addresses the unique aspects of multi-LLM collaboration, including metrics that reflect the collaborative dynamics and outcomes. Overall, the paper highlights the necessity for a more nuanced approach to evaluating multi-LLM systems, moving beyond conventional single-model benchmarks.
What results were reported to demonstrate the efficacy of multi-LLM collaboration, and how do these results compare to existing models in terms of performance and user representation?
The paper highlights that multi-LLM collaboration enhances factuality and reliability by allowing distinct LLMs to evaluate and reflect on each other's outputs, which helps identify knowledge gaps and reduces hallucinations. This collaborative approach has shown superior performance in various experimental settings compared to single LLMs, which often suffer from confirmation biases and outdated information. Additionally, multi-LLM systems address the underrepresentation of diverse user needs by enabling decentralized and participatory development, allowing contributions from a broader range of stakeholders, including those from underprivileged backgrounds. In contrast, single LLMs typically reflect the priorities of a homogeneous team of developers, often overlooking the diverse values and perspectives of actual users. Overall, the results indicate that multi-LLM collaboration not only improves performance metrics, but also democratizes the development process, making it more inclusive and representative of real-world diversity.